o'clock. So I'd like to welcome everybody back to the Reynolds Company's user group for 2022. We were originally going to do these in person beginning of the year, but we decided to push that back a little bit. So just stay tuned. We're hoping to get back in person soon, but we decided to hold that off in at least another month. So here we are on January 19th doing another
Zoom
virtual
call
meeting. But thanks for joining in and tuning in. So today's call is going to be kind of an overview, an introduction to Rockwell controllers and I/O. So later on this month, we're going to have a tech talk, or second tech talk of the year, which will cover the Stratus industrial Ethernet. So stay tuned for that. Should be a good one. And then next month will be an introduction to Rockwell Automation operator interfaces. So the panel views and a lot of the other technology that Rockwell has as well. So that's going to be next month. So tune in for that. And again, all these resources are available on our website, reynoldsonline.com. So we store all these and archive them to use for anybody's use going forward. So if you did miss a topic, jump on our website and you might be able to find it there. So today we're going to have three presenters. Myself, my name is David Newt. I'll be presenting, along with Wayne Welk and Mike Masterson, all automation specialists between Houston and New Orleans. So let's go ahead and get started. Before we jump into it, just a quick reminder that we are the Rockwell Automation distributor, but in addition to that, we do support a lot of our other automation solution partners, including ProSoft and Stratus and Panduit and Pepperl and Fuchs and all these folks. Of course, Thin Manager is a Rockwell technology, but don't forget all these other products that complete the Rockwell solution. So that was a quick advertisement for our partners. So let's go ahead and get started on controllers. We're going to start with controllers this morning. We're going to start small and get big. And so this is a kind of a review, just but also an update to let you know what we still have left in our MicroLogix system. So as of today, we've got the MicroLogix 1100 and the 1400. And as of this morning, I checked Rockwell's Lifecycle website, and the MicroLogix 1100s are at end of life. And the expected discontinue date is March 2nd of 2022. So we don't have much time on these. And I think we've been communicating this throughout, probably the last 18 months, a couple of years, that these are going away. If you do need any of these, you need to contact your salesperson right away, because there's really, even with a discontinued date in the future, there's no guarantee that these are available. But officially from Rockwell, we've got until March 2nd for orders on the MicroLogix 1100. And again, the 1100s were really small, 16 point up to really more, probably less than 50, but I guess technically you could get a little bit more with some of the expansion modules if you added expansion to it. But the 1100 is going away. So the 1400 is the only active MicroLogix product that we have left. And so MicroLogix 1400 has fit a really good niche for a long time. It's, I would say, that among the MicroLogix was the larger of the platforms. It's a good fit for systems that were not large enough for Logix platform, standalone islands of automation type of stuff. But the 1400 is the last active product that we have, and you can expand it with the 1762 expansion IO. So that's still an active product. But again, it's the last one. So sort of the writing is on the wall that it's a good idea to start looking at the newer micro platform, which is the Micro 800. And so I'll spend the next few slides talking about the Micro 800 family as a whole. And the Micro 800 certainly could replace a 1400 application at the higher end that we'll talk about in a minute. But the full platform here starts out with the Micro 810, which is really a relay replacer. It's really sort of like a basic relays and also timers built in. It's really not a PLC in my view, but it's a maximum of 12 points. The Micro 820 is really when we kind of get into that PLC functionality. And it's a smaller system, 20 to 36 points. It's got Ethernet IP. It's got some other features that you would expect in a controller that we'll talk about. Then the 830 is the smallest micro that supports motion. So you can do simple motion with the Micro 830. Does not have Ethernet IP. So small, very small motion standalone systems. And then the Micro 850 and the 870, those are sort of, I would call the sweet spot of the 800 system. They're a little bit larger systems. You can expand them quite a bit with different types of IO and Ethernet IP support as well as motion. So let's go into a little bit of detail on the 820. The 820 does not have any expansion, but it does have two pluggable slots that you see there that are blank on the screen. So it's got a little bit of expansion available. Now it has a built-in Ethernet IP port as well as a serial port, and so that built-in serial port can be used either as RS-232, or there's also a remote, very small remote LCD display you can plug into it. And so that LCD display has a keypad. It also, you can put up to 4 rows of data on it. It's IP65 rated. So for a really small micro type application with a very small data view look, this would be a good option for that. It also has a micro SD slot, so you can do backup, you can do some data logging on it as well. It's got a USB port as well to download to the controller. So a really functional, small type of system, very cost effective. Price range of these, we're talking about 820, probably $150 to start. Very, very cost effective system. Then the 830 is a little bit of a step above, really mainly because it supports simple motion. So if you want to do just a very up to 3 axes of motion and a standalone system, this is something you may want to look at. It does have a 485 port that's not isolated. And it also has 2 pluggable slots there. And there is a isolated serial module that you can add on one of the pluggable slots for the 820 or the 830. So if you need an additional serial. So again, this is really just your entry level, very entry level motion controller, the 830. We don't sell a lot of those here, mainly because it doesn't have any Ethernet IP, so no Ethernet network capability. So the 850 is probably our bread and butter sweet spot for the micro system. Again, you're talking a low cost point for quite a bit of functionality. As you can see, the 850 has up to 5 slots for pluggables, and it's got a built-in Ethernet and a 485 port and a USB port for different connectivities. And in addition to the 5 plug-in slots, there's also up to 4 expansion IO modules. And so the expansion IO, will talk a little bit about the differences between the expansion IO and the plug-in slots. The expansion slots are a little more capable and add to the size of the physical size of the controller as you add them on. But there's quite a bit of options with the expansion IO slots. And so at a maximum, the 850 can go up to 192 IO points. So that's quite a bit of IO for a small system. And a very, very good cost point. It's also high speed inputs and outputs are supported on the 850. So I would say that we probably sell more of the 850s than any of the other micro 800s in this marketplace. Then a couple of years ago, Rockwell introduced the 870, I think maybe back in 2019, and as to be a little bit more capable than the 850 for a little bit larger systems. So if you use the 850 in the past and maybe needed more data memory in the controller, the 870 has double the memory available than the 850 has. Still the similar support for Ethernet IP, a little bit extra capabilities on the motion side. There's 3 plug-in slots, but you can have up to 8 expansion IO modules. So using some of the high density modules we'll talk about from Spectrum, you can get up to 300 IO on this system. So very capable 870. So these are for probably what I would call the largest micro systems, outside of anything, anything large, much larger. You certainly want to be in the Logix world. MicroLogix or CompactLogix or world for that. So there's also there's a memory backup module that's available as a plugin, so you can expand that memory a little bit more on these systems. So very capable, especially folks that have been using the MicroLogix for a long time. If you haven't looked at the Micro 800, you really should, because you'd be pleased with the capabilities that the Micro has. So a little bit about the different types of modules. So the plug-in modules, which are available from the 820 all the way through the 870. The plug-in modules are typically, the IOs are very small point count. So I'm talking 2 to 4 channels, whether that's analog or digitals. But there's also some communication modules. So there's a serial port that's isolated that you can plug in. There's also a backnet port that pluggable that you can add. And again, these are available to use for the 820 all the way up to the 870. And they're very cost-effective modules, and they don't add to the footprint of your system. If you've got a really small panel and you can't add any expansion modules, the plugin would be a good option for you. And every time I talk about Micro 800s, we always talk about, in addition to what Rockwell makes, Spectrum has quite a few options of IO that really enhance the overall product. So we always like to talk about the Spectrum controls modules. So on the plugins of the Spectrum, you can have a 4 universal analog input. You could have 4 thermistor analog ins, backnet communication that's serial or Ethernet, and then 2 high current relay outputs, up to 10 amps at 24 volt DC. That's pretty interesting for a small micro like that.
Yeah, and David, if you don't mind me jumping in for a second, one of these lists of modules here show you one new area where the Micro 800 actually excels at. It's a nice little building automation controller using the BACnet modules and the thermistor inputs. Those are quite often seen in those type of applications. It's stuff you and I aren't familiar with because we do a lot of process control and stuff, but we always forget these are perfect for building automation.
Right.
Nice low cost controllers.
And you could add a thermistor and a BACnet to an 820, and you have a very low cost system. So which would be good there. So yeah, thanks, Mike. And then, so let's talk a little bit about the expansion IO. So expansion IO, similar to the MicroLogix 1400 and the 1762, where they add on to the DIN rail on the side. There's more capabilities on these, higher density IO modules for these, and really add the point count to the Micro 800. And these expansion are available in the Micro 870 and the Micro 850, not in the 830 or the 820. So that's typically when we get into using the 850 more often is because we need these expansion IO capabilities. And so Spectrum has us covered there as well. So you can see the different expansion IO options that Spectrum brings. So we can get really high density, even analogs on these Micro 800 systems, 16-point analog inputs. We've got they've got an 8-channel universal analog. So that would be voltage, current, RTDs, and thermocouples. Really nice module. And then a combo card, and then a dedicated RTD card. So really good stuff. So really a lot of options here. And I guess that kind of finishes up the Micro 800. I guess I'll pass it off to Wayne, who's going to talk a little bit more about controllers. Did you grab it, Wayne? Or I tried to. Wayne, are you muted?
I thought I hit the mute button. I didn't. Sorry. Thanks, David. There we go. Off to a good start. We're going to switch gears to the Logix. And I was going to say there, I think there was a question in the Q&A on scales versus, any other scale partners other than Hardy. I don't know if anybody has a good answer for that while we're at that kind of transition point here. I don't know if Toledo has a ability to integrate into the Logix family or not.
Yeah, Hardy is the only one I know that has an actual plug-in module.
There you go. Okay. So we're going to switch to the Logix family and the small controllers. And I guess, one question here would be, hey, what about the SLC 500? We didn't include that here in our kind of overview. SLC 500 is, of course, still an active product. I guess it's would be listed as active mature in Rockwell's definitions and their lifecycle policy. So just meaning that, yes, it is still around. It's been around since the 90s, but there is, of course, newer technology out there, such as the CompactLogix family here. So we wouldn't necessarily lead with a SLC 500 on projects unless there was a real good reason to do so. But David talked about the micro family, which is a great fit. We move into the Logix family, and of course now we step into the Studio 5000 programming software for both the CompactLogix and the ControlLogix, and we're really trying to take advantage of the integrated architecture with all the other Ethernet IP products from Rockwell, such as the ease of integrating a drive, PowerFlex drive, into our controller, or E300 electronic overload, or power monitoring. So any of the Ethernet IP enabled peripheral products can be easily integrated into these platforms. And the CompactLogix and ControlLogix also both share the same instruction set. So it's a real easy process to kind of take a CompactLogix project and move it into a ControlLogix, or vice versa, depending on the size and requirements of your system. So other thing kind of note here as we switch into this section is this will be kind of real high level. I know we've done lots of presentations over the last year on maybe some architecture things such as redundancy and other kind of system architectures. We can always talk about that in future, but this will be more of a kind of high level on why one versus the other, perhaps what makes one CompactLogix different than the other one. So we'll start out with the L1. So first off, the numbers too, right? So there's lots of numbers in the Rockwell world, and we use the 5370 and the 5380 kind of as our number here to reference what generation of CompactLogix controller we're talking about. So 5370 would be what we would also call kind of the L7 family. That was kind of that previous generation. I guess we'll call it the 7th generation. The 5380 is the L8 family. That's our next generation processor. So they both coexist. And another common question is, 5370, is that going to go away? The answer to that is no. It's still an active product, and we still sell quite a lot of the 5370 family. Yeah. So, yep, go ahead, Mike.
Oh, Wayne, I was going to say, I use as a differentiator the 5370 and everything below it is a dual core processor. The 5380 and the 5570 ControlLogix, those are all quad core processors. Learning this, where the demarcation point line is now kind of important. We need all of our customers to understand that, because not all of the new IO that's being released today, and I'll talk about this later, can work with every controller. A lot of the newer IO will not work with the 5370 type controller. You have to use a quad or something that has a quad core processor.
Yep. Yeah, Mike will cover the IO here in just a short few moments. So we'll start with the L1. The L1 is kind of the lowest end of the CompactLogix family. What makes the L1 unique is it does have embedded IO right into the processor itself. You have 16 in and 16 out, discrete in, discrete out embedded right in the processor itself. And you could support up to 8 expansion modules. And if you notice in the picture on the L1, so the type of IO that the L1 uses is actually the slice type IO, the same that's used with the point IO family or the 1734 IO product. So if you were using the L1, it's a little bit of an outlier in that you have a different IO onto it, and it's designed for a much smaller system and at our kind of our lowest price point, but takes advantage of all the Logix capability in that L1. We move to the L2, which also has embedded IO, 16 in, 16 out, discrete. Also supports some embedded analog in one of the versions of it. But what makes it different than the L1 is that we can now use the 1769 IO on the end of it. So it's kind of the same IO platform that we would also use in the L3 family. So the L3 is kind of our most common one, I think, at least perhaps from what I see. And the L3 is just a standalone CPU, or I should say a CPU by itself, not any embedded IO in it. And you would, of course, use all the IO is now, you would kind of stack on to the side. It also uses a separate power supply you kind of see in the middle of that L3 picture, whereas on the L1 and L2, the power supply is actually built in to the CPU kind of brick itself, 24 volt only. Whereas when we go to the L3, you have the ability to spec out a 120 volt AC power supply or a 24 volt DC power supply. The L1, 2, and 3 all have USB ports and all have 2 Ethernet ports kind of hiding underneath on the bottom. Those are 10/100 megabit Ethernet ports, and it's one IP address only, even though it's 2 ports. So it's kind of a built-in switch for ring type of architecture. And then, as Mike said, the 5380 or L8, that's our quad core. So it's a much higher performing processor. It is also another number in here is the 5069. So you'll see the prefix, on anything time you order the 5380 CompactLogix is its 5069 in the front. So just to kind of confuse you a little bit, 1769, of course, is for the previous L7 generation. So again, lots of numbers to throw around. So the 5380 is our kind of just our controller. There is a 5480, and what makes that different is it has the CompactLogix or the Logix control engine on one side of it, and it's a Windows IoT embedded computer on the other side of it. So it's kind of it's 2-in-1, both a Logix controller and a Windows computer all in one unit. So talk a little bit about, see if I can, it's the slide here. There we go. So when we look at the difference in the 5069 family, it kind of comes down to, these are the model numbers, and it comes down to memory, as well as the amount of expansion IO that can go onto the newer controllers. So the 306 is the lowest end of that family with 0.6 megabytes, 8 expansion modules, and up to 16 Ethernet nodes with no motion. So motion control in the 5380 family will be indicated with an M at the end. So the ERM, the M for motion. So you can see we have, so if you're choosing your controller here, you have different sizes, based on memory. The processing capability is the same no matter what, just the amount of memory is what changes in each of the models, and the amount of expansion IO, as well as the number of nodes. And we say expansion IO, that means like what can actually be attached directly to the CPU rack itself. You can, of course, do remote IO and bring in more IO, but if you want to just stack, you can stack up to eight cards on that CPU if it's a 306 or a 310. So it's important to understand that too, because when you build up your system, you find yourself with 9 cards, then you might want to move up to the 320 in order to not have to break it into a remote IO, another Ethernet remote IO rack. So let's move into ControlLogix. That's of course the what we kind of classify as our large control system, and of course the flagship and what's been around for quite some time as well. And kind of similar to the CompactLogix family, there's been several previous generations, and what Rockwell has always done there is, as those older generation CPUs become harder or impossible to manufacture, they come up with a new generation of processor. And in the ControlLogix case, it's been really straightforward. You can take out your previous generation processor and put in your next generation processor, and everything else in that rack can typically stay the way it is. Sometimes, depending on circumstances, like if it's a redundant system, you might have some other modules that might have to move forward too. But for the most part, you can easily move forward as technology changes in the ControlLogix family. And we call it a large system because those CompactLogix systems from the previous slide, there was of course a cap to the amount of IO that could possibly be handled in those systems. As we move in the ControlLogix system, that we have much larger IO capability for very, very large distributed type systems. Very large number of Ethernet nodes that can be attached as well. So again, that's kind of why we call it a large control system. And just like in the CompactLogix family, we have kind of 2 current CPU generations out there. If you have some older stuff in your plant, you might be familiar with the L5 or L6 processors. Those are some examples of older processors that have been discontinued, but you can easily move up to what we call the L7 or L8. And just like in the CompactLogix world, the L7 or 55770 is a dual core processor, and the 5580 is a quad core processor. So there is the guy in the middle. Just kind of included him there just to show that there is a kind of what we call the ARMOR ControlLogix. So I would say we probably don't see that a whole lot in our area, but that is an IP67 rated ControlLogix kind of as an on-machine product. There's no I/O in that. You would basically attach everything over Ethernet to a remote I/O. So to kind of give a little, just some of the specification differences and why would you pick one or the other? Say, do I need quad core? Do I need dual core? It's still, there's lots of reasons why you might pick one or the other. One of the advantages of the L8 controller is that it does have an embedded Ethernet port on the processor itself. So it could potentially save yourself an Ethernet card, depending on what you're doing with your networking in your application. Of course, the L8 family does have more memory on board and utilizes all that memory. Whereas in the 5570, there is some overhead use for the CPU, I guess OS and stuff. Whereas on the 5580, you have all 40 megabytes available to you to use if you're using that top end processor. The 5580 does have that embedded Ethernet port, and it does support 1 gigabit speed as well. So if you're trying to do some high speed communications, then you can take advantage of that gigabit speed in that port. Both the 5580 and 70 do support redundancy now. So the L8 redundancy was kind of a development last year. So and it requires version 33 in order to support redundancy in the L8. If you're doing the 5570 redundancy, then you can go back as far as version 20, as far as redundancy support. There's various versions that support redundancy. Communication options, both of them allow you to, there's a huge, again, with all the Encompass partners and from Rockwell, there are lots of, options for communication modules that can go directly in the chassis. So there's a large collection of different cards. So if you're looking for something, trying to connect to something, odds are we can probably find, if it's not an in-chassis solution, then we typically can find some kind of gateway that can at least get us from Ethernet IP to whatever communications you need to get to. So another thing that kind of came out last year for the 5580 family is some different controllers in the family. So some with different capabilities. So you'll find that when you look at your catalog numbers, it's a 1756-L8, and the X would just be the number, the model number, and then the E would stand for Ethernet. So that's kind of the base standard controller. But then we came out with a few other flavors that may or may not be something you need to use, such as the NSE for no stored energy. One thing I didn't discuss there was, when you looked at the L5 and L6 processors, you had a battery. When we moved to the L7 family, there was no battery. We used what was called a stored energy device. And it basically was a capacitor that could hold the RAM up long enough to allow it to move the program into a non-volatile memory space. So the L7 and the L8 take advantage of that kind of capacitor, that stored energy device built into the processor itself. Well, in certain circumstances, if you may not want that stored energy, that might be a potential hazardous, explosive environments. You may not want that capacitor sitting there. So there is now an NSE version for those applications. The K at the end, anytime you see a K at the end of a Rockwell part number, it would typically mean that it's a conformally coded processor. So there is a K version, standard catalog number. XT for extreme temperature. So that gives us a little bit higher temperature scale, up to 70 degrees C. And in some cases, a lower temperature range as well, for those rare cases where we need to go below 0 degrees Celsius. And P now is the process controller. So we now have a separate, kind of a purpose-built process controller in that L8 family. Process basically meaning that the process objects library is now built into the firmware of the processor itself. So just to help provide a better performance in process control. And the S is for safety. So there is also a safety version, the red ContRolLogix, so safety version of the L8 family as well. So when you look at the L7 family, we have a standard controller, we have a conformally coded controller, we had an XT L7, and we had a safety version, but there was no process version of the L7. And of course, the no stored energy doesn't have that option either. So these are a few extra enhancements from the L8 family. So just a little bit more of a comparison between the L7 and L8. So you can kind of see that if the L7 5570 was kind of the bench, the benchmark there, or the baseline, I should say, then the 5580 is looking at 5 to 20 times, performance improvement over the L7 family. Memory again is going to be the base model on the L8 is 3, and it goes up to 40 megabytes. Motion, the L8 can handle more motion access per controller. The other big difference in the L8 and L7 family is the number of connections versus nodes. In the L7 family, we look at the connections on Ethernet. This is going to Ethernet connections. So in some cases, some remote IO drops could take multiple connections, right? It's not just a simple, hey, one connection per whatever device I'm connecting to. Some devices took 3, 4 connections or more, perhaps. Whereas in the 5580, we're looking at the number of nodes. We're not counting connections. So we're only looking at, how many devices are really connected there. So a remote IO drop would count as one node, regardless of how many cards are on that node. A panel view would count as one node, right? So it's kind of an advantage of the L8. Makes it much easier for us to understand. Now, the little breakout to the side just shows on the right-hand side of the screen, does show that, based on the model CPU you choose, the number of nodes do differ. So if you're at the baseline 81E, the smallest in the family, you get 3 megabytes of memory, you have 100 nodes, whereas you can get to 300 nodes if you're using the L85E. All right. So again, if you're kind of trying to determine L7 versus L8, first off, you look at performance, the quad core versus dual core, look at the number of connections versus nodes. So there's some things we might ask. You need embedded Ethernet or not. So there's always plenty of reasons why to use one or the other. The other question here would be, hey, the L7, it's still an active product. It's still there. So no plans to get rid of it in the near future. And it does support up to version 33. So the L7 family for Studio 5000, is going to work from version 20 all the way up to version 33, which is the latest version of Studio. Whereas the L8 family kind of came in, I think, around version 28. And so it's going to be 28 through version 33. So if you're trying to support some older, versions of installs of Studio 5000 for any reasons, and you can't move up to a newer version, perhaps the L7 is still what you want to look at there as well. All right. Another kind of thing on the, you'll see kind of what kind of came about in the last year is just a kind of a new look to our to the controllers and to our products. Kind of give a little bit of a shall we say, a cooler look and easily indications as to what type of processor each one is. Anytime you see red, that's safety. The darker gray is typically the XT, but it also is indicating the process as well, because the process controller is actually an extended temperature processor as well. It has conformally coded and has extended temperature capability standard, so in the P controller, so it's also the dark gray. And then of course the NSC and the K there are the lighter gray, and the standard is the lighter gray. So easier labeling, easier for to kind of determine which one's what, just by looking at the front of the product. And, oh, well, so we still have this guy in here. This is just to show that, we're talking about the process controller for the P controller, but when we talk about process safety, we didn't show the guard logic slide earlier for machine safety, but just to kind of show that we do have also have process safety. We could do that in ControlLogix platform up to SIL 2, and then we also have the advanced and the trusted products that can get us up to SIL 3. So you have some process safety applications. Definitely talk to us, and we can help determine what's the right platform for your application. And with that, I think I am done. We'll turn over to Mike to go over IO.
All right, thank you very much. David, are you still driving?
I had taken control.
Then I will take
William's
control
driving.
myself.
I'm giving it up.
All right. Is my screen coming up?
Yeah,
guys?
Still see the IO platform.
Okay, great. Thanks, everyone. My name is Mike Masterson. I'm one of the automation specialists out of Houston. I work with Wayne and David. I'm going to be covering the IO platforms. And first of all, I'm going to break it down into a couple different categories. We're going to have our chassis-based IO, our process-based IO, then our washdown area type or on-machine type IO. So I'll break this down to you and cover some of the changes and maybe some of the life cycle on some of this. With ControlLogix, we have ControlLogix-based IO. The most important thing about this is it's all remove and insert under power. It does require a chassis and a power supply and a comms adapter. Currently, we still support Ethernet, and ControlNet has the comms for these racks, but typically where we see people using this is a lot of small process systems where people don't want to use the same form factor of IO throughout the facility. So that's why we'll use the ControlLogix part, or remove and insert under power is very important to them. These generally come in IO increments of 8 to 16 points, but we can do 32 points of discrete with them. And generally, there's not a lot of thought that has to go into this, except you have to remember to add the terminal block if you're purchasing one of these IO blocks, because we don't include those because you do have an option of whether you want screw terminal or spring clamp. The next IO, chassis-based IO we have is the 1769 compact IO. So this is the CompactLogix IO that we typically would use with the L2 and L3 type 5370 controllers. This can also be used as remote IO off one of the newer controllers, the quad core, which would be the 5380 and the 5580 type controllers. This comes together similar to like any older generation CompactLogix we might want to put together. You'll need a comms adapter. You will need a CompactLogix power supply. Then your IO modules will go to the left or right of said power supply. So it's a nice IO, good footprint, nice price point, but we're not seeing people use it as much for remote IO nowadays because they're more pointing towards its partner next to it, the 5069 compact IO. This is the IO that is based for the newer controllers. Again, the quad core. So this will work with the 5380 and the 5580 CompactLogix, but you cannot use one of the older gen processors such as a ControlLogix L7 or the 1769 CompactLogix. Those do require a quad core processor, so that's one reason why we can't use this. Now, we'll go into a little bit more detail on what makes this a really nice IO shortly. We're going to come back and revisit this one. Now, the in-cabinet IO. We have the point IO that's been around for ages. The points generally come anywhere from 2 to 8 points on this. There are a few exceptions to it. You are required to have a comms adapter. And unique thing about this is you can actually put up to theoretically 63 modules on this off an IO adapter. In practicality, you don't want to do that. And the 63 nodes is kind of important because any of you old school guys who remember DeviceNet, that was the limit on DeviceNet, because that's basically what we're running across the backplane for the comms on it. So this is really nice IO, especially when you have a small footprint. If you just need to put IO in a junction box, this works perfect for you. Why it might not fit your needs is it can get expensive if you're doing a lot of alternating of different voltages, because if you are running some 24 volt and some AC 120 volt out of this IO, you will need to put a voltage injector in between that, and if you're doing a lot of that mixing and matching, it can add up. But for small footprint type installations, point IO works very well. Now we have our Flex IO. This is a much higher density than the 7034 IO, and this is a mature product. It's been out for quite a while. It will work with both the L7 MicroLogix controllers and the L8s. And typically discrete increments, we get up to 30 points on it, and the rest of the cards are generally 8 or 16 point. Again, this is very high density. The wiring looks very nice to it, because all your terminal blocks are on the bottom or on the side, because one unique thing about this product, you can mount it either vertically or horizontally. So that will give you quite a bit of density in there. Now, next to it is the Flex 5000 IO. This is it looks similar to the 1794 IO, but it is definitely not the same product. It has the same footprint, but it is made to go, we're actually calling this part of our process IO. It's has a lot of the same features as a lot of our higher end product. The backplane on it is 1 gigabit. The comms adapter for it is 1 gigabit. And this is the first IO platform we have where we have an option not to use copper RJ45s. We actually have a comms adapter that we can use SFP, so we can take fiber directly into this remote IO. So people have been asking for this for quite a while, so that is now a viable option. We can support both a device level ring and parallel redundancy protocol out of it also. So that's another reason it's part of our process IO. Also, the heart cards are available for this, and we do support Heart 7. Now the 1715 IO, that is a specialty IO, and I will say that probably is going to, we have a new product coming out at the end of the year that I'm going to address that. It has a lot of the same functionality, but for whenever we're doing a redundant system, especially if it's a safety rated system, we tend to want to use the 1715 IO. The IO, it gives you the ability to have redundant comms adapters, redundant power feeds. It's a redundant backplane. And also the cards can be used in either a simplex or a duplex form fashion. So if you have certain safety loops that you need to have duplex, you can certainly use 2 cards. But if some are not part of the safety loop and you just want to do a simplex, you can put 1 card in there. So it works out very well. The wiring terminals are on the top. It is a different form factor, and if some of you who might say, well, this looks a lot like the ICS product is, because this is the advanced IO that's been adapted for our use. And now we're going to take a look at the on-machine IO. The Armor Point is a hardened version of our Point IO. Same functionality. It uses DeviceNet across the backplane. Again, it's invisible to you. You'll never see it, but that's the comms it's using. but the IO blocks generally are 2 to 4 points. And the thing about this is we're not putting this in a cabinet. It's out of the box. It can be, has an IP69K rating. And so it's good for NEMA 4X right out of the box. We don't see it in our market a lot, but quite often where you'll see this is where you might have robots, welding machines, or any place, any assembly line, food and bev also is where they'll put it, where they don't want to put junction blocks. They want to put the IO block directly next to the equipment. One thing you'll notice, it uses M8 and M12 connectors for the IO. So it makes a very clean install when you're just trying to connect sensors directly to your input block. If you need any information on it, just please reach out to us. But one big takeaway is it does support device level ring. So it is very much networkable. Now we also have safety related IO, and the IO you're being shown here is mainly for shutdown systems. It's not for fault tolerant where we need to keep something up. But so this is for your assembly line. This could be for a roller coaster. I like to use anything where we have to shut down the process to a safe state. So we have safety rated IO for armor block point IO, the 5069, the 1756, and the Flex 5000 IO. And I will be addressing some new product we have for the safety products for the Flex IO. This is kind of exciting because I've been talking about it for quite a while. The Compact 5000 IO system. What's nice is we can put up to, this is a very nice high density IO. One thing you'll notice about the IO cards itself, 8 to 16 points, the actual terminal block pops out in a much nicer fashion than the old 1769 IO. There's LED indications for pretty much everything on it. It's much easier to troubleshoot. And it takes a very small footprint to get relatively high density. So this is definitely an IO we want to make people aware of, that this is more than just CompactLogix. This is a remote IO platform used, and there are safety cards for this. So with this, we get it's not a remove and insert under power, because obviously it's a stick together backplane, but we can support up to 1 gig on it. So it fits motion applications very well. And the big caveat here is we have to use this with the newer controllers, the 5380 CompactLogix, 5480, which is the CompactLogix with the PC built into it, and the 5580 controllers. So the Compact 5000 has to be used with one of the quad core processors. Please keep that in mind. Now we're going to talk about our process IO, which is what we consider our Flex 5000 and the Flex HA, which we'll talk about in a little bit. The Flex 5000 is a relatively new platform for us. Again, it looks like our older Flex IO, but none of the parts are interchangeable. The IO, it is remove and insert under power. It is a high temperature. If you look at -40 to +70, if you were to use one of our high temperature processors, the XT processors, which Wayne talked about, this is the IO platform that goes along with it. So this is our high temperature IO. It's all class 1 div 2. Channel increments are generally 8 to 16 points. We have a full range of safety IO for it now, which we'll go into a little bit more detail. The wiring blocks stay in place just like the old Flex, and the actual IO module will pop out for remove and insert under power. Very, very nice platform. And it's also the platform, if you need to get the highest density in an enclosure, this is what you want to use, because it can be mounted horizontally and vertically, and you can put up to 16 IO modules off one of the comms adapters. So It also gives you the ability to umbilical. So if you do need to use 16 IO modules off of it, but you only have space for 2 rows of 8, we can use an umbilical to separate those two. So it's a very flexible IO for high density panels to use. We do put a QR code, and you'll start seeing this on a lot of the Rockwell product. And this is actually for asset management down the road. So we can have knowledge of exactly what equipment's being used out in the field. So be aware, you're going to start seeing a lot more QR codes on our equipment. Dual LEDs, there is an expansion cable, and again, the high temperature rating for it. And again, one of the other things that makes this a process IO is the comms adapter allows for different topologies of Ethernet. We can do a device level ring, a star, a linear network. More importantly, we can also address the parallel redundancy protocol, where we have to have 2 distinct channels to the IO rack. So this IO does support it. It also, again, as I mentioned earlier, it does have a comms adapter that uses SFP adapters, so we can take fiber optics directly to it. And this is just showing the mounting capability of it, both vertical and horizontal mounting. Now, let's talk about the safety part of it. We've had the safety discrete for quite a while. We've had that probably for the past couple of years. Those cards have been available. So we have a 16-point input, 16-point output, and a relay output also, which is actually kind of unique to this product line. This again, we can take this up to a SIL 3 machine safety shutdown type system. It's not fault tolerant IO. Again, this is for a shutdown type system, but we do have those modules available. And nice thing about this platform, we can mix and match safety and non-safety IO in this application. Some information about some of the older cards, but what I really want to talk about is they've just released the analog safety IO modules. We talked about this a little bit last year, but now I will say this with a caveat. They are now, the part numbers are in the Rockwell system and they aren't in our system. I don't know what the lead times are on them, but it is a viable product as of today. So we have a 4-channel safety analog input card and a 4-channel analog output card. This is the first time we've actually had a safety rated analog output card. So this opens us up to more process opportunities. HART is built into these cards, and we do support HART 7 with them. So this is actually kind of a big deal. This has been a hole in our product line for quite a while. So it's nice to have this here. And also, as part of the safety analogs, we have the thermocouple RTD combo module and actually a frequency input module. So we have this is brand new IO. This really does fill a hole that we had in our line to be able to SIL 3 temperature loops and maybe some motion control on the frequency inputs. So please be aware that these are out there and they're truly available. Now I'm going to talk about mythical things. Rockwell they sort of talked about it at Automation Fair this year, but they have the Flex HA 5000 IO platform. Most of you, probably 90% of you, have not seen this before. We are going to see this IO at the end of this year. It's going to be a November, December timeframe. Originally, we were hoping we were going to have this before May, but there are some issues with supply chain. Of course, most of you guys haven't heard that. So it has been pushed back to November, December timeframe. So I will talk a little bit about it, but this is our fully redundant IO, and I see this as becoming our go-to process IO. It is redundant network adapters, redundant power inputs, redundant backplane, and redundant IO. And similar to 715, you can card it out for either being a simplex or a duplex IO point just by using 2 cards. The wiring arms are down on the bottom of this particular IO, and it does support highly integrated HART and a HART 7. And it, as you notice, it also has the extended temperature range already built into it. So as we get more information, we'll go into it. There will also be a universal card for this. So I don't have a lot of details on it, so I'm not going to really speak to it because we are a few months out. But they did show this at Automation Fair this year, so it will be out. And this is going to help us, especially on the networking part. We will have 2 separate comms adapters to be able to run to. So we can easily do a PRP or a DLR type network off of it. And the redundant backplane, it really will be able to give us a nice fault tolerant IO solution. So this is something to look forward to, and we will also be able to take fiber directly to this chassis. A little bit of a breakdown, as a lot of you will notice, it's laid out in a similar fashion to our 1715 IO or the triplex. You have your comms adapters and your power modules on the left hand side, and then IO as you're looking at it, my slide, and on the right hand side are your IO modules. And those, obviously the red ones are safety, black ones are standard, but those can be put in together a redundant fashion, or you just use 1 card and it would be a simplex type application. So something to look forward to at the end of the year, and as we get more information on it, we'll definitely bring this to your attention. And with that, David touched upon this briefly, but we do have Spectrum Controls does make a lot of specialty IO for the Rockwell platforms. So if you're looking for something like a universal analog input card for 1769 IO, Spectrum makes it. So if you have questions on whether Rockwell has a product, it's always good to take a look and see if there's something specially that Spectrum Controls might also make for it. So I want to bring that out, especially in a lot of these subsystems. A lot of the universal analog cards we've been using have been Spectrum Controls. So I just want to make you aware of that. When we put together bills of materials for you or quotes, you might not recognize it, but a lot of times we might be slipping these type of IO cards into your application based on what your needs are. And with that, I guess, are there any questions? Anything we can answer for you?
Well, Mike, there was a couple of items in the chat I wanted to address back on the Micro 800. First of all, Dennis, thanks for the question about the programming tool for the Micro 800. I forgot to mention that in my talk. Micro 800 is programmed with connected components workbench, so that's separate from the Studio 5000. CCW, as we call it, there's a free version of that that's downloadable, and there's also a developer edition that gives you a couple of extra functionalities. So the Micro 800 uses CCW. It's also the same software that you can use to configure drives as well, and also the Micro 800 HMI is configured with CCW, so it's a multifunction programming tool. So I forgot to mention that. And also there's a question from Vaughn about the noisy signals with the built-in analogs in the 820. I have seen that. So one thing to keep in mind with those pluggable modules, especially the analogs, is those are, first of all, they're not isolated. Second of all, they are only 12-bit resolution modules, so you're not going to have the accuracy that you would expect to have in a Logix, analog module. And if you're using the Micro 800 and you need more resolution, the expansion IO modules from Spectrum are 16-bit. So that's where, honestly, that's really why if we're doing analogs, a lot of times we'll move up to the Micro 850 because we know the expansion IO analog modules are, a little more accurate and give you better readings. Those pluggable modules are great for quick and dirty analog signals, but if you need a lot of accuracy, you need to move to the expansion analog modules for that. So thanks for that question, Fawn. And that's all I see in the chat. I don't know if there's anything else you guys saw or wanted to address.
Okay.
I think it was answered. There was one about the process, which ControlLogix processor had the process library built in. It was the ones with the P at the end. I think didn't mention too that there is a CompactLogix version of the P controller in the 5380 family, the L8 family. So there is a P controller in the CompactLogix family too. And I think that is it.
Okay. Well, with that, thank everybody for attending. We look forward to seeing you hopefully soon down live and in person. Let's cross our fingers. We're on tentatively shoot for March on that. But look forward to seeing you next week for our Stratus update. And if not, then our next users group next month in February.